right. The topic, as you can see on the screen, is sectional views. Sectional views. Before we go fully into the lesson, I would like us to look at the objectives so that you can know what you are to bear in mind and what you are to focus on in this topic. As we have here that at the end of this lesson, you should be able to explain one, sectional views, two, cutting plane, three, section lines, and four, state and identify each types of sectional views. So those are the things that you need to bear in mind, that you need to be watchful, and you need to focus on them so that you will not miss anything in what I'm to teach you today under this topic, sectional views. Now, let's look at the introduction. So in the introduction, we have that in engineering industries, when the internal features of an object is complicated, it is very difficult to visualize the object from its orthographic views, since there will be several hidden lines. So what are we talking about? Now, as you know that we have different engineering components that are complicated. An example is this mouse. So this mouse that I'm holding in my hand here is also an engineering object or engineering product. So as you can see it, as small as it is still a complicated engineering object. And by doing it from outside, we don't know what is inside. We don't know what is inside. So to know what is inside of it, to know how the interior part of this object is, or the internal part of this object is, that's why we need to talk about sectional views. That's why you need to learn about sectional views. When we talk about sectional views, it has to do with the cutting of an object like this. By cutting it, you can cut it into two, or we cut a quarter of it, so that we can see what is inside of it. So by the time we cut it into two and we put down what we have, which are hidden from us when we are looking at it from outside here, so when we put them down, whatever we draw, based on how the interior part of this object is, as we have cut and we can see what is inside, so whatever we draw, or that views that we put down, is known as sectional views. Now, I'm going to explain you with the diagram that we have in the notes. So let me read on so that I will explain all that we have here. And then we have that in such case, the internal details are shown by sectional views, as I've said. So sectional views are an important aspect of design and documentation, since it is used to improve clarity and reveal interior features of parts. So let me explain this with this diagram that we have here. Now, if you look at this diagram, now, in this diagram that we have here, I'm trying to, I want to highlight it. Okay, now in this diagram that we have here, now this is the object. This is the object, this is the complete object, and then this object is now called. Normally, this view that we have here, these views that we have here, they are the orthographic views of the complete object. If the object is not cut, we have it as a complete object, and we are looking at it from a particular direction. We are looking at it from a particular direction. So this, what we have here, are orthographic views of this object. They are orthographic views of this object. Okay, so what we have here are orthographic views of these objects. So when we are looking at it from outside here, some parts are going to be hidden from us. As we have here, we have some hidden details here, drawn with short dashes line. So, but if we cut it as we have here, so what we have here, where we have full section view, is that the object has been cut. We are now looking at how its interior part actually looks. So that's what we have here as full section view. Now, let's move on. Now, sectional views, as we have here, so what is the meaning of sectional view, or what we have to understand by sectional view? As we have here, sectional view is the view obtained after cutting the object in order to show the inner details by an imaginary cutting plane. So the imaginary cutting plane is like a knife that used to cut an orange. You know, when you cut an orange and you remove the upper part, so you see a rough surface. You cannot see the interior part of the orange if you don't cut it with the use of knife. But by the time you cut it with the use of knife and you remove the upper part, that surface that you have that looks rough is actually the sectional view. By the time you draw it, if you draw it on the paper, so whatever view that you have is known as the sectional view of the object. So the sectional view shows the shape of the section as well as all the visible edges and contours. So what this is saying is that by the time you remove the front part and you are looking at the other part, so whatever you see will give you the actual view of the interior part of the object. Now let's move on. All these stories, they are important, but we need diagrams to back them up. Now, another thing that you need to know about sectional view is what we call cutting plane, which I've said before. So cutting plane or sectional plane is an imaginary plane by which the object is assumed to be cut. So as I said, that is like a knife or a saw used to cut a wood, maybe a saw used to cut wood, or an hacksaw used to cut a metal. As we have here, this is a saw cutting this object. Now, this saw is cutting this object, and it cuts it, and we remove the front part. So the part that we have, that is this part that we have here, this is what we see. So we are able to see the interior part of the object after cutting it. After cutting, we are able to see the interior part of the object after cutting it. So this saw is the cutting plane. We call it cutting plane when it's come to sectional view. And the cutting plane is represented with this line. So it's represented with this thick long chain line. Okay, so we also have these are cutting planes. So these are the type of line that we use for cutting planes. Now, sectional line or section lines. So section lines are lines used to represent the material which has been cut by a cutting plane, and we also call them hatching lines. Now, as I said, these section lines that we have here, they are used to represent the roughness of the surface of the object that has been cut. As I said, that when you take a saw and you cut wood into two, so by the time you remove one part and you are looking at the other part, you see a rough surface. So the roughness of the surface is shown with the use of section lines. So if you look at what we have here, so we have to avoid this type of section line. If you section like this, or if you draw the section lines like this is not correct. If you draw it like this is not correct. That's why we have avoid, and this is the preferred one. So you have to make it like this. So section lines are thin, equally spaced, parallel, and inclined, drawn in that area of the view where the cutting planes cut the material of the object. So we usually draw the section line with the use of a 45-degree set square, and they must be equally spaced, and they must parallel to each other, and they must incline at an angle which is angle 45 degrees. So take note of that. Then the next thing that we want to talk about here is types of sectional views. Types of sectional views, very, very important. So we have the following types of sectional views, though we also have other ones. But these ones are the ones that you need to get yourself familiar with when it comes to technical drawing in WAEC. So these 6 are enough for you to study. So whatever they want to give when it comes to sectional views will still be part of this one. So these 6 ones, these 6 that I've listed here, please pay attention to them. Now, number 1 is full sectional view. 2 is half sectional view, partial or broken out section, offset section, reverse section, and removed section. So let's look at them one by one. So first of all, we want to look at full sectional view. In the case of full sectional view, we have that this is the sectional view obtained after removing the 1/2 portion of the object through its center line by an imaginary cutting plane. What the cutting plane does is that it cut the object into 2 equal parts. As you can see here, this is the cutting plane. So it cut the object into 2 equal parts, as you can see here. So here we have the object, the cutting plane cut it into 2, and we separate it here with cutting plane standing in between them. Then, now, this is the cutting plane now. This is the cutting plane. This is the orthographic view of the plan of the object and the cutting plane cutting it into 2. So this is the correct one. This is the correct one. And when we produce the sectional view, this is what we get. This is what we get as the sectional view. So this is correct. So take note of this. So the next one that I want to look at is half sectional view. In the case of half sectional view, what the cutting plane does is that it cut a cutter. We have 2 cutting planes that are inclined at right angle to each other, as you can see here. We have 2 cutting planes that are inclined at right angle to each other, and they cut a cutter of the whole of the object. So that's why this is what we have. This is the isometric views or pictorial views, and here we have orthographic views. So this is how the sectional view is going to look for half section view, as you can see it here. What we have here is orthographic views for these 2. This one and this one, they are orthographic views. While what we have here, this is the cutting plane that cuts the cutter of the object, and we have the sectional view looking like this. So take note of this. Then the next one that I want to talk about is broken or partial section, broken out or partial section. So in the case of broken out or partial section, so we have that this is the sectional view obtained when the cutting plane is imagined to pass pathway through the object, and the piece in front of the plane is then assumed to be broken away, leaving an irregular boundary. So it's like we break this thing, we break it somewhere here. So we break this object somewhere here. And what we have here, this is orthographic views. While what we have here, this one is sectional view for broken out section. So take note of this. Then, next one that I want to talk about is offset section. In the case of offset section, what we are trying to do is that we want to reveal maximum interior part of the object. So that's why we have the cutting plane. So the cutting plane, it moves in this direction, goes in this direction, moves in this direction, goes in this direction, and also goes in this direction, for us to be able to reveal the maximum interior part of the object. So that's why we make use of a cutting plane that looks in this form. So when the cutting plane goes in different direction, in order to show more features of the object, So that type of section is known as offset section. And what we have here, so this is it. So we have the cutting plane. Cutting plane moves in this direction, and this is the sectional view for offset section. If you look at what we have here, we have 3 holes. So for us to see the 3 holes, the interior part of the 3 holes, that's why we have the cutting plane moved in this direction. So take note of this view, and you must be able to identify it when you come across it in exam. So the identification is very, very important. So the next one that we want to talk about is revolved section. In the case of revolved section, the cutting plane cut the object. Usually use it for use the revolved section for ribs, arm, and also bar. So, and when the cutting plane cut the object, let's assume that this object is cut into 2. This is how we are to show its sectional view. This is how we are to show its sectional view. So take note of the difference between this and this. So this is the correct one. Why this one is incorrect? I believe that you can see that we say it is incorrect because the lines pass through the sectional view, and which makes it incorrect. Likewise here. So take note of this. This is the correct one. This one is correct. Why this is incorrect? So take note of it. Make sure you can identify it. So next one is remove section. Remove section is similar to revolve section, but difference between them is that instead of the sectional view that is within the object itself in the case of revolve section, in the case of remove section, we bring out the sectional views, we separate the sectional view from the object itself. So that's what we have here. So this is correct. And then here we have what? We also have remove section here. So the sectional view is brought out separately. So we take it away from the object and we set it out like this. So take note of this. Okay, the next thing that I want to talk about is this details not section. Details not section. So there are some things that are not sectioned when it comes to the assembling of objects. For example, so when we put some components together, so there are some components that will not be sectioned, and I'm going to tell you about them here. So here we have that in addition to the examples given above of the omission of arching, some machine details are not sectioned on assembly drawings when they are cut longitudinally by the section plane. Now, for example, examples of the details that are not to be sectioned is a knot. So we have knots, we have bolts, we have screws, we have studs, we have rivets, we have solid shaft and small cylindrical parts, we have keys, we have cutters, we have splits and taper pins, ball and roller bearings, web spokes and ribs. So all these things, they are not sectioned when they are cut vertically. What I mean by that is that, look at this thing that I'm holding in my hand. If we cut them like this, that's what we call longitudinally. So by the time we cut them like this, it has no meaning anymore. So in that case, when we assemble an object and we use bolts to join 2 components of the object together, we don't cut the bolts and nuts. We don't cut the bolt and all. We leave them as solid objects. So that we can identify them. Because even if you cut them, it has no meaning. So just leave it like that. So if the cutting plane goes down like this, we leave the bolts or not, we leave them in their normal form. But if it cut it in this direction like this, so we can show the roughness of the upper part like this. So take note of that. Okay. So what we have here, that note, these parts are not sectioned because they have no internal features. They are solid objects, so they have no internal features. There's no hole in them, so they are solid objects. So that's why we need to leave them as solid objects. And also, they are more easily recognized by their outside views than by a section. However, if these details are cut transversely, as I've shown you, resulting in a circular sectional view, they are hashed in normal way. So if they are cut like this, so you can show the roughness of the other part. But if it is in this direction, we leave them as solid objects. Leave them as solid objects. So, and I've done something here. Maybe you don't know what to call a screw. So this is screw. This is stud. This is stud. Then here we have these are rivets. This is shaft, and we have keys. So we have different types of keys here. So different types of keys. We have square key, flat key, dowel key, and here we have feather key, wood rough key, give head key, and taper key. So all these are very, very important. So you need to be able to identify them. Then this is a nut and this is a bolt. So these are all that I put together for you to know about sectional view. So don't forget what I've said about sectional view. We use the sectional view to reveal the interior part of the object. And I made mention of six different types of sectional views. We have full sectional view, we have half sectional view, we have partial or broken out section, we have offset section, reverse section, and removed section. And then I talk about the section lines. Section lines are also known as action lines, and they are drawn within continuous lines. They are drawn within continuous lines, and they are equally spaced. And they are parallel to each other, inclined at angle 45 degrees. I said use a 45-degree set square to draw the section lines. And then the cutting plane. The cutting plane is like a saw or a knife that we use for cutting things. So the cutting plane is represented with use of thick, long shear line with an arrowhead. Now, there's something that I need to say here. I want to quickly explain that. Now, when we use a cutting plane to cut an object, okay, let me use this as an example. Okay, now, if you look at this cutting plane, the arrows are pointing up. They are pointing up. What that means is that if we cut this object like this, as the cutting plane goes, we are removing the part that is this part. We are removing this part, this down part. By the time we remove this down part, what we see up here is what is produced here as the section of the sectional view. So take note of that. So the direction of that arrow is what, or the view in the direction of that arrow is what we are to draw as the sectional view. So thank you for listening. Please study this note very well, study it very well, and watch this video very well. So, and then if you have not subscribed to my YouTube channel, please subscribe so that whenever I upload a new video, you get a notification. Keep on studying, keep on practicing, and I see you at the top. God bless you. Thank you.